Let us discuss about limit and limit point. When I was reading about this, I was confused. At first I thought they are same, then I realized that they are different, but I was not understanding how they are different. I just knew they are different. So if someone else has the same confusion, I think this video is certainly going to help you. Let us start with the definition. So the definition of limit point is this: let X be any metric space and let E be subset of X. A point P is a limit point of the set E if every neighborhood of P contains a point Q which is not P, such that Q is in E. So in order to claim that P is a limit point of this set E, we have to have this condition, that is, every neighborhood of P has to contain any other point other than P, and that point has to be in E. So if it satisfies this definition, then we say that P is a limit point of the set E, right. So the main condition is that every neighborhood of that point has to have a point which other than itself. One thing which we need to observe here is that limit point is defined for a set. See, it is kind of very obvious when we see the definition, but these things are going to create a confusion when we read further. So we have to understand this, and we have to we have to remember this point, that limit point is defined for a set, period. Okay. Let us move on to the next definition. What is a limit, right? So that is, let X be any metric space. If a sequence Pn in a metric space X converges to P in X, then we say P is the limit point of Pn. So whenever we have a sequence Pn and Pn converges to, if Pn converges to P in X, then we say that P is the limit of sequence Pn. So limit is defined for a sequence. Okay, limit is defined for a sequence. Whenever we have a sequence, we can speak of limit of a sequence if it is convergent. Okay, we have a possibility that a sequence may not be convergent at all, right. We can have, so we do have a possibility where a set will not have any limit point. So all the possibilities exist. Now, what is the relationship between limit and limit point, right? What is the relationship? Because once we understand the relationship, then it becomes it becomes easier for us to further understand the theory. If we don't know what is the relationship between limit and limit point, then that really creates a confusion. So in order to understand the relationship between limit and limit point, at first we have to understand this definition, that range set of a sequence. What do you mean by range set of a sequence? I think it is completely evident by the name itself, range set. For example, if we take the first example, -1 power n, the range set of this sequence is -1 and 1. That means the range set contains these two elements, that is -1 and 1. Okay. Now here if you take the sequence 1 by n, the range set contains infinite elements, and they are 1 by n, where n is a natural number. So here the range set was finite, here the range set was infinite. So you just see the range set. I think you understood what a range set is, right? Now let us move on to the next slide, but yeah, before that, one thing you have to understand, that is, for every sequence there is a range set, corresponding to each and every sequence there is a range set. It can be finite, it can be infinite, but there is certainly a range set. So if you give me a sequence, then corresponding to that there is a unique range set in each case, right? So a sequence may have a limit, right? If it is convergent, then it will have a limit, Again, you have a range set here. So now so the relationship between limit and limit point is that the sequence, whenever we deal with a sequence, that might have a limit if it is convergent, and the range set may have a limit point. We don't know, right? The range set may have a limit point. So for every sequence there is a corresponding range set, and we can discuss about the limit point of the range set of a sequence. So whenever we have a sequence may have a limit or it may not have a limit, and corresponding to that sequence there will be a range set, and that range set may have a limit point or it may not have a limit point. So one thing which I want to mention here, I know I have mentioned it as a moral of the story, that is, whenever we say limit point of a sequence, then that is a wrong statement, because limit point of a sequence does not make sense by definition itself, because limit point of a set makes sense, limit of a sequence makes sense. You see, carefully you have to understand these statements. Limit point of a set makes sense and limit of a sequence makes sense. So we can't interchange them. So whenever we have to want to discuss about the limit point, then what we have to do is we have to take the sequence, we have to take the corresponding range set, then we can discuss about the limit point of the range set. So limit point of a sequence does not make sense. It's a nonsense statement. So don't make that statement. That is the first point. Now let us understand this with examples. I think these examples are going to clear all our doubts, and I think these 4 examples are more than enough to understand this theory. See the first sequence. This is a constant sequence 1 1 1 1 1, right? In this constant sequence, if you see, the range set will have only one element in it. Okay, the range set will have only one element, that is 1. This sequence is a convergent sequence and it converges to a limit 1. So the first example, this first example has a limit, that is 1, and the range set has only one element, that is 1, and we know that a finite set in any metric space, finite set will not have a limit point. So the range set of this sequence does not have a limit. See the second example. In the second example, the sequence is converging and it is converging to 0. Okay, and the range set is also, it has infinitely many elements. It has 1, 1 by 2, 1 by 3, as we discussed in the previous slide, and that range set also has a limit point and it is 0. So in this case, the sequence has a limit and the range set has a limit point, and the limit and limit point are same in this case. You see, let us see the third example. The way in which I constructed the third example is like all these odd terms are 1, 1 by 2, 1 by 3, 1 by 4, in general 1 by n. All the even terms are constant, that is 2019. So we know that this sequence is not convergent. This is a divergent sequence. But if you see the range set, which is this set union this set, this has a limit point. So this is the third example, is telling us that you can have a sequence which does not have a limit, but the range set will have a limit point. Let us see the fourth sequence. The fourth sequence is not convergent and the range set contains only 2 elements, so it's a finite set, so it does not have a limit point. So the fourth example is like you can have a sequence which does not have a limit and the range set will not also have a limit point. So the first example was like sequence had a limit but range set was not having any limit point. The second example is like the sequence has a limit and the range set also has a limit and they both coincide. Third example is like sequence is not convergent, it does not have a limit, but range set has a limit point. Fourth example is like sequence does not have a limit and range set also doesn't have a limit point. You see, these 4 examples are quite enough to understand the difference between them, and I think these 4 examples are really going to clear all our confusions. Now, before ending this video, I have taken this paragraph from J.F. Simmons. I want you to just read this paragraph where he is explaining that there is a difference between limit and limit point, and they are often a source of confusion. That's what he is saying. When I was reading Simmons, that was the time when I realized that there is a difference between limit and limit point. Till that time I used to think that they are the same. And here he is also mentioning a theorem that if a convergent sequence in a metric space has infinitely many distinct points, then its limit is a limit point of the set of points of the sequence. See the way he is writing the then statement here. You see, its limit is a limit point of the set of points of the sequence. He is not writing limit point of a sequence, because that's a wrong statement. As I said, he is writing limit point of the set of points of the sequence. So we have to be very careful while using while making any statements in limit and limit points. I hope you enjoyed this video, or at least it helped you to understand the difference between limit and limit point. Thank you for watching. Hope to see you in the next video.